Hello everyone, we are going to graph the function y equals sine x today, and we're going to see where it comes from based on the unit circle. Okay, so taking a look at our unit circle here, we have our unit circle, and we want to make sure we know what is showing here on the unit circle. Remember, we have our angles all the way around in degrees and radians. I've put them on there. You'll notice something is missing on this unit circle. I only have put in the y coordinates for this unit circle, and that is the reason for that is we are graphing y equals sine x, and sine x refers to the y coordinates. So what we're actually going to be graphing on our x-axis is the angle. Okay, so this is the angle measurement on the x-axis, and on the y-axis is the sine of that angle. Okay, the sine of that angle, which from our unit circle we know is the y coordinate. All right, so if you have not done so already, I would like you please to orient your paper in a landscape orientation. Draw a unit circle like this showing only the y coordinates for the sine, and also figuring out where your y equals sine x graph will be. Notice that the x-axes line up together on the unit circle and this. And the y-axis, I have a separate y-axis for each, of course. The scale on the y-axis is the same though. Okay, so that's why I came up at this sort of awkward 7 grid marks here, because I drew my circle first, and that's how tall 1 was. So I made that 1 and then 7 grid marks down on my graph paper for -1. Okay, please also, as you're drawing this, make sure, so pause the video here so you can see it. Make sure you can see how these black numbers, okay, so pi over 4, pi over 2, 3 pi over 4 pi, and so on, are 2 grid marks spaced apart from each other. Okay, and then the red ones, I just put in red so you can see that they are also equidistant. Okay, if we count the pi over 2's and the pi and the 3 pi over 2 and the 2 pi, they are all equidistant. So if we think about, this is how I figured it out. If we think about from 0 to pi over 2, we need, it's easy to put pi over 4 in because that's halfway between pi over 2 and 0. So pi over 4 was easy to put in there. But then we need pi over 6 and pi over 3 all the way to pi over 2. Okay, so in other words, we need two spacings within this pi over 3 spacings. One gap here, 2 gaps here, 3 gaps here. So we need 3 spacings within 4 grid marks. So 4 divided by 3 is 1 1/3. So every 1 1/3 grid marks is 30 degrees or pi over 6. Okay, so figure out your scale that way as well. Important to use graph paper so we can do this well. All right, so pause the video and make sure you have this set up, your unit circle with only the y coordinates and your graph with this scale on it. Okay. If you wish, you can also add in the degrees here. Okay, so this would be 30 degrees, 60, 90, 120, and so on. It's just going to get really messy if you do that, so I'm not going to do that. And most of the time, these types of graphs will be using radian measure and not degree measure. Okay, so important to get used to seeing that. All right, gonna move this a little bit. Hopefully there's not too much glare there. All right, so you've got that all set up. Now you're back. We are going to see pi over 4. Okay, so remember, x-axis is the angle measurement, so pi over 4. Y-axis is the sine of that angle. So at pi over 4, here's our pi over 4. The sine of that angle is root 2 over 2. Okay, so what number does that approximately equal? We'll talk about that in a minute. Okay, let's go back up here to pi over 6. Pi over 6, 30 degrees. The sine of pi over 6 is 1/2. So that's an easy grid mark to put in here. 1/2. I'll use purple because that's my pi over 6 is at 1/2. So that's actually an ordered pair here, right? So our ordered pair, pi over 6 for the x coordinate and 1/2 for the y coordinate on this y equals sine x graph. Okay, because if we did a table of values for this and our x coordinate, y coordinate, x coordinate pi over 6, okay, so plug that pi over 6 in here. Sine of pi over 6 is 1/2. Okay, so that would be an ordered pair. All right, again, I'm not going to list all the ordered pairs on here because it will just get messy. All right, do we have anywhere else on this unit circle that actually has this measurement, this y-axis measurement of 1/2? Yes, we do over here. It's not very well drawn to scale, but it's this one over here at 5 pi over 6. So 5 pi over 6 also has this same height on our y equals sine x graph. Okay, now let's look at the other purple ones. We have 7 pi over 6. Can you see over here? Yep. 7 pi over 6, and that's negative 1/2. Okay, so 7 pi over 6 comes down to negative 1/2. Oh, I think I put this in a little bit of the wrong place actually, because it should be 1 1/3 grid marks away. It should be a little bit closer there. Okay, all right. And the other purple one, 11 pi over 6, is also negative 1/2. So that's there. So these are all points on the graph y equals sine x. All right, let's do our blues. All right, so root 2 over 2 is it's this height. Okay, so we're halfway in between here. Root 2 over 2 is here, so that's pi over 4. Pi over 4 is here, so that's 5 and a little bit grid marks up on my diagram. The next one, 3 pi over 4. So also here. And then blue down is 5 pi over 4, that same distance down. So 1, 2, 3, 4, 5, and a little bit grid marks. 5 pi over 4, 1, 2, 5 there. And also 7 pi over 4. And here. Okay, so those are actual points on the graph y equals sine x as well. All right, let's do the green. We have root 3 over 2. So about up to here, that's pi over 3, root 3 over 2, and also 2 pi over 3, root 3 over 2. You can get your calculator out and figure out that decimal number for root 2 over 2 and for root 3 over 2 if you want. It's 0.7 something for root 2 over 2 and 0.86 something, I think, for root 3 over 2. You can figure that out if you would rather get it more exact. And the 4 pi over 3. 4 pi over 3, same distance down when you're only here, and 5 pi over 3 as well. Okay. All right, so this is starting to come together. Now let's put in our black points here. The 0 degree, 0 degrees is 0. Okay, so this graph starts here. Pi over 2 is 1. Pi is 0. 3 pi over 2 is negative 1. And back around to 2 pi is 0 again. Okay, so you can see how this graph is shaping up. We could continue going. We could keep going around in the circle if we wanted to. We could go all the way around and continue another pi over 6, or I'll just go to the next pi over 4. So this would be 8 pi over 4, 9 pi over 4, and then 10 pi over 4, which is 5 pi over 2, 11 pi over 4, and so on. You could keep going around the circle 12 pi over 4, which is, oh my goodness, 12 pi over 4, 3 pi, which is then all the way around and half a rotation more. We could keep going and the same pattern will continue, but let's draw in this pattern now. This is actually the graph. Okay, and we could keep going. And we could keep going back in that direction as well with the negative angles, starting from here and doing negative angles. Okay, so this is y equals sine x. We are going to be doing a lot of investigations with this. You will have documents to download and to fill out and send to me based on y equals sine x and then the transformations of y equals sine x. Have fun!